Okay, so we're recording right now, and our notes for today, and today is 12/3/2012. So we're about 22 days off of Christmas, and our goal for this objective is we're going to be able to apply the second derivative test. So we're going to review really quickly. F prime is the slope. If f prime is greater than 0, this implies f is what? Increasing. This should be obvious at this stage. If f prime is less than 0, this implies f is what? Decreasing. Okay? If, yes?
How many derivative tests?
Just 2. Okay. And good question. If f prime is 0, this means there exists, yeah, a horizontal tangent line at wherever at some x value. All right, and then that's also an extreme value if it does not exist. So at this stage here, we would have something like this or something like this here. So at this stage, so here f prime is bigger than 0. Here f prime equals 0, and here f prime is less than 0. The same thing is true for here f prime is less than 0. Here f prime is 0, and here f prime is greater than 0. This is all review, okay? Most of you should have this in our pocket here. So this is review. What we're going to learn today is what double prime means, which you already know. You just have to connect it to prior knowledge, okay? So this is we're gonna bank on prior knowledge from pre-cal. So this is new stuff here. So double prime, f double prime is the slope of the slope. Okay, so this tells me how the rate is changing. This f double prime is basically for concavity. Concavity. So we're going to connect these over here. If f double prime is greater than 0 on some interval, this implies f... Oh, sorry. Yes. So f double prime is the slope of the slope, and basically when you're doing double prime, it's the concavity of the function. And if you remember concavity, if you don't know what that means, if you forgot, that's okay. It's the cave. This is concave what? If you don't know, write it down. Concave down. And this here is what? Concave up. Okay? And so if f double prime is greater than 0, this means f is concave up on some interval. Okay? If f double prime is less than 0, this implies f is concave down on some interval. And if f double prime is equal to 0, right, or, I should say or, does not exist, this is where we have a point of inflection. Okay? And a point of inflection is where, this is where the concavity changes. So where the second derivative is 0 or does not exist, it's where the concavity changes. So it's basically almost exactly like the first derivative test, okay? So the point of inflection separates the intervals of concavity here. Okay, Quentin, yes?
In these problems, whether you get f prime from 0 to these, the same thing?
Yeah. It's still critical values that we need to check here. So what we're going to do right now is an example, and we're going to look at how we apply these problems here.